to Math 9. Today we're going to be going over the notes for 2.5, Exponent Laws 2. Please fill in your notes as we go, and if you have any questions, make sure you're sending me an email. What do you think will happen if we have a power that is acting on another power? So if I have something that looks like this, okay, thinking about what you know, what does this actually mean? Okay, so in the past we have all been using order of operations, which means that we need to solve what's in the brackets or parentheses first. So that would be 2 to the power of 3. So that would actually look like 2 times 2 times 2. And 2 times 2 times 2 is actually 8. And that whole thing would have been squared, which becomes 8 squared, which is 64. Okay, so this is what you would remember from the past. Now, to make it Math 9, how or what is the other way that we could simplify this equation before solving? So the first one is still 2 times 2 times 2. And what the exponent of 2 means is that I am taking what's in my parentheses and I'm multiplying by itself twice. So I could actually write it like this. So 2 times 2 times 2 is 8, and times 8, which is 64. Do you see how it's still the same thing? Now in our last lesson, you guys notice that if I'm multiplying a number by itself, okay, I can group them together. So how many times am I multiplying 2 by itself in total? 1, 2, 3, 4, 5, 6. So this could be simplified to say 2 to the power of 6. And if I took out my calculator and put in 2 to the power of 6, or if I just did the math, I would still get the same answer of 64. So how do I go from this step to this step? What do you think the rule is going to be? The exponent law for a power of a power, or to raise a power to a power, is what you may see. All we have to do is multiply the two exponents. So you could see here that 2 times 3 would actually give me my 6. Okay, just like before, our base cannot be 0. It has to be an actual number, whether positive or negative. So what would it look like if there was more than one number inside the bracket? So again, more than one way to do this. In the past, we would have said 3 times 4, which is 12, and that would be 12 to the power of 7, okay, which is going to give us an answer of 35,831,808. But how would we be able to use our new law to solve this? So this one is actually fairly simple to do this, and you'll probably do this, but it's still important to know this law. So if I have a base, I have an exponent. It's a hidden exponent, but it is always there, and that is 1. And the rule is that the power to a power means that I'm multiplying my exponents. So it would become 3 to the power of 1 times 7, which is 7, times 4 to the power of 1 times 7, which is still 7. And if I did the steps to solve this, I would be getting 2,187 times 4 to the power of 7, which is 16,384. And if I multiplied the two of them together, I would be getting, the same answer of 35,831,808. So I get the same steps by using my law, or the same results. Okay? When you are working, you are able to use both methods. Okay? You're going to probably use the one that makes more sense to you, but it's still important that you spend the time to review and practice using the actual laws. It is important to remember that the exponent on the outside of the bracket is multiplied to every exponent that is inside the bracket, uh, even if they don't look like they are there. Ooh. Even if they don't look like they are there. Okay, so don't forget that there is a 1 there. So if I were to just do a single power to begin, so this is what it's asking you for, not the final answer, just as a single power. It means that I am just multiplying my exponents. This would become negative 7 to the power of 6, because 3 times 2 is 6. This one would become negative 2 to the power of 20. And the last one would become 6 to the power of 14. Okay, so if it asks for a single power, it means you have to use your law to simplify. If it asks you to evaluate, then you're finding the answer, and you can use either of the two methods. So method 1, solve what's in the parentheses first. Negative 7 times 5 is negative 35, and negative 35 squared is giving me 1,225. Or I'm using my lots. This is going to become negative 7 to the power, there's like hidden ones there, negative 7 to the power of 2 times 5 to the power of 2, which is going to be positive 49 times 25, which is going to give me the same answer of 1,225. So both methods would be correct and get you the mark. For the next one, okay, we need to know that the number on the outside is being multiplied by every number on the inside. And if it's a fraction in the question, it should be a fraction in your answer. So this one is actually going to become 78 to the power of 3, because there's like a hidden 1, over 13 to the power of 3, because there is a hidden 1. And so 78 to the power of 3, which gives me 474,552, divided by 13 to the power of 3, which is 2,197. So 78 to the power of 3 minus 13 to the power of 3 is going to give me 472,355. Okay, so this is the kind of work that we are expecting to see. Now you're going to have to put all of the things together. They will often ask you to simplify and then evaluate. Okay, so make sure as you are doing these things that you are showing all of the steps as you are working. Okay, so I'm going to use our laws to solve it this time. Okay, so I'm going to start by looking in the brackets, and if I'm looking inside of these brackets, I know that if I multiply with the same base, I can add the exponent. So that's going to become 3 to the power of 5. This whole thing is in brackets to the power of 3. I'm going to do the same thing over here to simplify. My base is 4 in both of them, and I'm multiplying, which means I'm going to add my exponents. So that's becoming 4 to the power of 5, and this whole thing is squared. Now I'm going to use the next part, or the next law that I know, and that is if I have a power raised to another power, I'm multiplying my two exponents. So this is becoming a base of 3, and 5 times 3 is 15. And this one is becoming a base of 4, and 5 times 2 is 10. So I'm going to be saying that 3 to the power of 15, because now I can't use my laws because I'm subtracting, I actually have to solve it independently, is 14,348,907. and I am subtracting 4 to the power of 10 from that number, which is 1,048,576. So if I subtract the two from each other, I get a final answer of 13,300,331. Okay, so I used my laws to simplify first, and then I solved. So pause the video if you need, take a second to attempt to do these on your own. Again, there's technically more than one way that you can do it. As long as you're following order of operations and use the laws as needed, you should get the same answer in the end. So I'm going to say 6 times 7 first, which is going to be 42, and then that answer is going to be squared. And I'm going to add, my base is the same, and I'm dividing, so I am subtracting my exponents. So I'm adding 3 to the power of 2, and that whole thing is raised to the power of 3. So I have another law that I can use here. So right here, because I have two power exponents next to each other, it's a power raised to another, I'm going to multiply them, which gives me 3 to the power of 6. So in the end, I'm saying 42 squared plus 3 to the power of 6. So 42 squared is actually 1,764, and 3 to the power of 6 is 729. So if I add my two answers together, my final answer is 2,493. There are some practice questions for you to be working on that can be found in your textbook. Please, once again, take your time and answer them and show all of the steps as you are working. If you have any questions or concerns, please make sure that you're sending me an email. Have a great day.